Alright. Officially, welcome to another PLD session on Python programming. And in today's session, we are looking at flow control in Python. In fact, this is a concept that you should understand for every programming language and not just Python alone. So let me, as I always do, try and break down the concept of flow control so that you understand it, even before we take a look at the syntax in Python. Based on what we have done already, the previous PLD sessions that we've done already, you realize that almost every program that you write is actually executed from top to bottom, okay, in the order in which you typed your code. So if you said print this, take an input, print that, take an input, like no matter what, I mean, whatever you had in there was executed from top to bottom, okay? But there are certain instances, even in our lives, almost everything that we do, we take decisions. So we should be able to give that kind of ability to our programs. Our programs should be able to make decisions. Because if a computer cannot make decisions on its own, then it's going to be a bit difficult to get it to do any task at all. Because then it just become, even though it's a robot, but then I mean, one that cannot have any inch of thought isn't what you are looking for. You want to give your computer or your program, depending on what you are doing, the ability to make decisions based on certain conditions. So today, for instance, this afternoon, I had to make a decision whether to hold this PLD or not, because it was raining heavily and I needed to move from the house to the office to come and host the PLD session. So when you want to make a decision, usually it is binary. Either I do it or I don't, like that kind of decision. So it's either we hold the PLD or we don't hold it. But then what is the condition? I was looking at, okay, should the rain stop, we'll hold it. If the rain doesn't stop, we won't hold it, okay? So that is where we are looking at making decisions, okay? And if you are able to give this ability to your program, then you are able to control the flow. So I said that previously, all that we have done, the flow is straight, right, from top to bottom. The code is being executed in that order. But we want it to execute certain things based on a condition. So we are controlling the flow. And practically, there are two major ways that we can control the flow. We can use what we call conditionals that we are going to start talking with. Then we can use loops. Okay, so now let me just quickly jump to what conditionals are. Then let's start talking about conditionals. With the example that I was given, whether to come and host this PLD or not. So I had to look for a condition. The condition was, has the range stopped? Has the range stopped? Okay, has the range stopped? If the rain has stopped, I'm going to come to the office and host the PLD. If it hasn't stopped, I'm not going to come. Okay, so that is the condition that I'm checking. Then we are looking at a binary situation. So this is more of a yes or no answer. And I say that if it is yes, then I'm going to host the PLD. If it is no, then I'm not going to host the PLD. So if it was a program that we're writing, that this program should inform people whether they should host a PLD or not based on this condition, then we're also going to give that ability to our computer so that our computer will now determine that, oh, has the range stopped? If you say yes, okay, go ahead and hold a PLD. If you say no, then no PLD today. Okay, so in Python, the conditional statement that we can use, there are three major ones, but I mean the main one is the if statement. Okay, just that in peculiar cases, we combine if with other statements. So we can have if with an else. So that becomes the second one. Then we can have if with an or if, and an else. So this is 1, 2, 3. Just follow me. It will all make sense soon. So now let's just focus on the if statement. And almost everyone here makes that kind of decision where you make a decision to do something if something is true. So here, when we are dealing with conditionals like an if statement, the first thing you want to look out for is what the condition is. And what happens is that you are always looking for the condition if the condition is true. Remember, if what? True. So you should always consider what your condition is. Condition. What your condition is. Then, if your condition is true, you are going to do something. If it is not true, then you are not going to do it. So today I said that let me find out if it has stopped raining. So the question is, or let's say it has stopped raining is the condition. It has stopped raining. Stopped raining is the condition. So you ask yourself, has it really stopped raining? Okay. Has it stopped raining? No, it does not stop raining. If it does not stop raining, it means this statement is what? False. So I'm not going to execute anything. I said if true. Remember this, like anytime you are using the if statement, you only execute what it wants you to execute, or you do what it wants you to do if and only if the statement or the condition is true. Please pay attention to that. If and only if the condition evaluates to true. So if it has stopped raining, then I'll go ahead and do whatever I wanted to do. So hold a PLD if it is true. Okay, hold a PLD. So basically to write this in Python, this is how we write it. You just have your if, so you start with an if. Then you have the condition. Then followed by a colon. If you remember what we discussed about Python syntax, okay, a block of code is usually separated with, the column indicates a block of code, and after the column you have to indent whatever comes after it. So here will be a statement to be executed. To be executed. All right. So statement to be executed. Maybe comment this out. What I need you to pay attention to right now is just this part, the condition. No matter what you are given, always check this condition. If this condition evaluates to true, I know why I'm saying this over and over again, because a lot of people get confused along their line. The statement here should only be executed if this condition evaluates to true. Okay, so let's take another example, more practical example. Let's say that I want to check if, let's say, I want to check if the people joining the session today are in cohort 7. If you are in cohort 7, I'll send you a greeting. Okay, so what do? I check if, then I'll say member, this I'm just writing, member is in cohort 7. That's what I intend to do. If you are in cohort 7, I'll say welcome member, something like that. Just by the way. So now I start with each of you and I ask, Daniel, which cohort are you in? Daniel is in cohort 7. That means that this is true. So I can go ahead and print welcome member, or depending on how I write it, welcome Daniel. Okay. Then I ask another person, Mary, which cohort are you? Says, oh, I'm in cohort 6. Then member is in cohort 7. No. So Mary is not in cohort 7. Therefore, I cannot print this statement to them. That's basically what we are saying. Okay. So let me get my machine up and running, then we can start translating this into code. See projects. Oh, where? I think they're supposed to be or it's in Python programming where we are keeping our stuff. Okay, cd Python PLD. All right. So I'm trying to open VS Code right now. Great. Then we'll start typing something. But then, just as I said, we are only looking for conditions that will evaluate to true. If the condition evaluates to true, then we can go ahead and use the execute whatever is in the if statement. So saying age, maybe we should do something with age. And the question is, say we check the age of the person, and if the person is above 70 or 60, we say we print their pension message for them. Okay, so let's see, we can do something like that. If statement 1.py, then write this. Okay. For now, let me bring up the interactive terminal, then let's work in there before we go and write the code. Great. So basically, I want to create a variable called age, and it's storing the person's age. This person is 78 years old, and I'm asking a question: if age is greater than what? 60. It means that person is on pension. So we can go ahead and say, print something for them and say, you must be on pension now. Okay. So at the end of the day, all that we need is to find out if this statement here or condition here is true. Age, as was given, age is equal to 78. So if I say age greater than 60, what does it evaluate to? Does it evaluate to true or false? Okay, so basically here you find out that age is actually greater than 60 because 78 is greater than 60. That means that our statement here is going to be printed out. Okay, so that's why we have you must be on pension now. As simple as that. Please, it is that simple. But then all that I need you to remember is that whatever statement that comes or condition that comes after if, you should only consider it if it is true. Then whatever is in here is going to be executed. So if I go ahead and I now say if age is less than 60, then I do the same thing to it. I say print you must be on pension now. Say the same thing to this person, then run this program. It has ended without outputting anything. Okay, this first one output, we had you must be on pension now, and the only reason why we had it was because age, as we have here 78, was actually greater than 60. So it's like this whole thing is replaced with true. Then when we go here, age is less than 60. So now it is not true. This is false. Once it is false, our statement here is not going to run. I mean, the statement in here is not going to run. Okay. Once we know this, let's quickly introduce the else statement. Then, all right. So, in normal sense, you don't just based on one condition and say, I'll do this, like age is 60, is greater than 60. What if it's less than 60? What else will you do? Okay, so you realize that even when I was using in the English sentence, I said, what else? So you do this or that. You do this if this is true, else you do something else. And basically, that's what we do in programming. We say if something is true, okay, If something is true, we go ahead and do something. Let's call this statement 1. Else, that is, if this is however not true, what should we do? So else, go ahead and execute statement 2. As simple as that. So if we go back to our program, if you go back here, instead of just checking for one condition, we can check for, we can have the both sides. So if age is less than 60, if age is less than 60, print you must be working now. Okay, that's what we want to print if the person is less than 60. Then the next thing that we want to check is if after checking this person is actually not less than 60, what should we do? So we say else what should we do? Print you must be on pension now. Okay, so the only thing that is happening here is that we are checking this condition that you have been given, is it true? If it is true, go ahead and execute what is here. If it is not true, then go into the else block and execute what is here. So at the end of the day, age as we have is 78. Age less than 60, 78 less than 60, no. That means that this statement here is not going to be executed. Rather, the else block will be executed. So if we go ahead and run this, it says you must be on pension now. Okay, so let's get into our program and write this program that tells us if somebody needs to be on pension or not. Then Python 3, say we want to say check if someone is on pension or not. Okay, so that's what we are interested in. The first thing we want to do is to ask the person for their age. So what do we use? We use the input function, which we've discussed in previous PLD sessions, already published on YouTube. So input, then let's pass the information. What's your age? What's your age? Leave room, some space, then come down. Now that we've gotten the age, remember that, I think I should have done that. Remember that this input function always returns what? A string. So if you want this to use this for the comparison as we want it to do, we need to typecast it, or we need to convert the type from string to integer. We can do that by passing this to the integer function. Okay, so this will force whatever answer the person gives, will force it to become an integer. Then we can go ahead and use the if condition and say if age is less than, in Python you can make do without the brackets, but personally I prefer to use, the parentheses. Personally I prefer to use it so that it puts the logic in one place and I can reason it out to see whether it's true or false. Okay, but then it's not a requirement in Python, so you can go without it. Is age less than 60? That's all we are checking for. If age is less than 60, we are saying that we are going to print something to you. If your age is less than 60, then you must be working now. You must be working now. However, if your age, so we go and say, please, you need to pay attention to how I'm indenting it. After the colon, all the statements that is directly under the if statement needs to be indented. Very important. So when you come to the else 2, Everything after it should also be indented. Okay, so else we are printing you must be on pension now. Okay, excellent. So this is a simple program that asks a user for their age, then tells them whether they should be working or they must be on pension. Very simple. Okay, clear this. chmod plus x. What's the program? If, okay. Now let's execute this our program. Hopefully it asks us for our age. The name is if. So it says, what's your age? And I say, I am 52 years. And it says, you must be working now. Okay? That's simple. In fact, all that I want you to pay attention to is whatever the condition is here. That is all. So now let's try and come up with another where we are going to do some, okay, string comparison or mathematics. Okay, let me write another program. If statement 2.py. What do I even quickly come up with something? Okay, so let me use any mathematics. I think this I need. I want to illustrate something before I move on to the next one. So let me use the Python interactive mode to illustrate that. Now what is important is if I have this, if and I write 1 is less than 2, which you all know that it is not true. 1 is less than 2. Then the statement I want you to do is print, say hello, just for else. I need you to print, you got this right. Okay, so basically all that we are doing here is we are checking 1. Is 1 less than 2? So I've told you that in each statement, all you pay attention to is what is inside your parenthesis. Evaluate what is inside the parenthesis and tell us, is it true or false? Once this is true, please always remember, once this is true, then this will be executed. But if it is not true, then this will be executed. So 1 is less than 2. Is 1 less than 2? No, 1 cannot. 1 is less than 2. Yes, 1 is less than 2. So it means in this case you are going to print hello. Okay? Yes, I actually meant 2 is less than 1. That's what I wanted to write. But then let's try something. In Python, there is this keyword that we use to negate something, where probably, I don't know if we've ever mentioned it here, but the keyword is called not. Okay, in other languages you see this being used, okay, but in Python mostly use not. So for instance, if I want to check if something is not what it is, so let's say well, let me try this one and see. With the same thing, put a not before them. That would be an interesting thing. Not 1 less than 2. Let me see if it gives me the outcome I'm thinking about. Then we say print, just for the purposes, else print, else print Okay. So let's go ahead. This time around, we have not in there. See what happened. Here we had 1 is less than 2, and we all agree that that is true. Here we had not 1 less than 2, and it's printing the else block. Can anyone, let me listen to you. Can anyone tell me, share their opinion on why this didn't print this, but printed the else block? Anyone? Yes.
I think is just, it means that the if statement is true.
Means
no, the if statement is not true. Sorry.
Yes, it's changing.
That's what I mean. That's why it printed the else statement.
Okay. All right. So let me illustrate this.
Okay. Can I talk first?
Yes.
Okay. Please go back to your code. Actually, I think for that first line, if not 1 less than 2, for the first statement, normally if you are going to check it, we know 1 is less than 2, which is true.
Yeah.
But because of the not, it will be the reverse of it.
Thank you.
The inverse of the. So wherever the case is true, it will be false. So wherever the case is false, it will be true.
Doc, myself, that's the way I understand it. Whenever
Yes,
you have a
yes.
not before a true statement, it changes to false.
Exactly. So thank you all for your submissions, and that's exactly what I wanted to hear. Anytime you have nots before a statement, okay, always you just try evaluating your statement. So the statement here we had was 1 less than 2, and we know this to be what? True. But now what it means is that you are checking if not true. If not true, that's what you are checking. Okay, and you remember that I'm saying your if statements, the content of the block, the if statements block will only be executed when the condition is true. But now you are saying not true. Not true is the same as what? False. Remember that. Okay, so in fact, like this is exactly what I've been trying to illustrate, because at times it confuses a lot of people. There will be some negation somewhere you are confused. And yes, it's not true. Like somebody say, okay, so let's say we wrote not 2 greater than 1. Then they will totally ignore this one and say, 2 is, I mean, if it was not 2 less than 1, they totally ignore this and say, 2 is not less than 1. So this is true. Okay, but then the not is very important. So every time you want to evaluate whatever your condition is first, then if there is a not is negating it. So if it is true, it becomes false. If it is false, it becomes true. As simple as that. But then the block for the if statement will only be executed if here is true. So for this particular one that we are having not true, it means that this is false. And therefore, our if block will not be executed. Rather, the else block is what is going to be executed. Please, I hope that makes sense. That's all that I've been trying to explain. Because I know, as for the normal condition, this is true. It's easy. Everyone can understand it. But when they begin to use a lot of conditions, okay, then it becomes a bit challenging. The other thing too that we should pay attention to is using the logical operators. In fact, not is one of the logical operators. So the logical operators, I think in the last 2 PLD sessions we had, I talked about it. We can talk about AND, we can talk about OR, we can talk about NOT. So what logical operators will help us do when we are doing conditionals or trying to control the flow of our program is that it helps us check for multiple conditions. Okay, so with AND, Basically, we are looking at, say, statement 1 or condition. Let me call it condition 1. If I write condition 1 and condition 2, okay, and condition 2. What is important here is this logical operator AND. AND will only return true if both sides are true. So if condition 1 is true and condition 2 is also true, then this whole statement is what? True. That is for AND. If any of these tend to become false, AND will be false. I hope that makes sense. So if I go and check, say I want to check if 2 is greater than 1 and 17 is less than 3. Okay, this is the condition that you want to check. So the first thing is evaluate this condition, then evaluate this other condition. So here 2 is greater than 1. Is it true? We have yes, it's true. So we have true, and 17 is less than 3. Is it true? That is false. So at the end of the day, this our conditional statement is this: if true and false. Once you are using AND, this true and false is false. For AND, you only need, it will only become true if both of them are true. I hope you can remember that. So this condition, every time when you have a conditional statement or when you are creating your own conditional statement, that's what your focus should be on. All right, whatever is in there, if you want to explicitly execute this, make sure that whatever is in here that you are checking is true. Okay, let's take OR, the logical OR operator. Or on the other hand, will tend to be true if one side is true. So if at least one side is true, it will be true. So true or false is equal to true. True or true is equal to true. Then false or false is equal to false. Okay, so far as one side, so if I write, say, false or true, I'll still end up getting true. So far as one side is true, all will give us true. So if you have a statement that says if 2 is greater than 1 or 17 is less than 3, you want to execute something, okay? What this is saying is if 2 is greater than 1, that is true, or 17 is less than 3, that is false. But then when we take true or false, it evaluates to, since we have one true and the logical operator is or, then it evaluates to true. So this is the final thing. Our statement is true. I mean, the condition is true. So we can go and execute what is inside the if block. I hope that makes sense. Then we've talked about the not. So let me introduce. There are conditions where we have multiple things. So let's write a program that will implement, say, the traffic lights. Okay, traffic lights. We know red, gold, red, yellow, green. Okay, so red, yellow, green. We know red means the person can go, so we are going to print you can go for the person. Then yellow means they should get ready, so get ready. Am I thinking at all? How did I write you go for it? Sorry. Stop. I want to reverse the traffic lights. Green means go. Okay. So basically, we want to write a program that when we have multiple conditions like that, already what we've looked at is if and else. So if you are just working with this, you could have written an if statement for each of them to check if the color. So what's the light right now? We ask the person what's the light, and maybe they tell us that it's red. Okay, so we come and check if the color is red, then we say stop. Then we write another if statement. If the color is yellow, we'll say get ready. If the color is green, we'll say go. But then this is not an efficient use of this if statement. So there is a third one that we can use, that is we have multiple conditionals in between. So we have the first if statement, then there is another if, okay? But this time around, since we already have the first if, it becomes else if. But in Python, we don't have else if, we have elif, which is also coming from else if. Okay, then you check for that condition. So we can have multiple of these else if, but the last thing that we always consider is else. So here we are saying that we are checking for a condition. If that condition is true, do whatever we write below here. If it is not true, go to the next condition and go and check. We are saying else if, check if this is true, execute what is here. If it is not true, go to the next one, go and check this, execute what is here. If it is not true, go to the next one. But if all of these, remember, for each of these, we are going to have conditions. Okay? But for the else statement, we don't add any condition. The else statement is if all the conditions I've set have failed, then the else is what is going to be executed. So let's go ahead and build our traffic lights program. We can make it as robust as possible, but then just for the purpose of explanation, I'll keep to what will make sense. Okay, so let's have this user bin Python 3. What this is going to do is give us directions based on traffic rules. Okay, so that's the program that we are writing. The first thing we want to know is what the current light is. Okay, so maybe we should ask the person to tell us what is the light, like what did you see. They will tell, our program will tell them what they should do. Okay, so it depends on how you write it. You can choose to make the program in strings. You can also choose to even use integers to represent them. All right, so let's try using both of them, then I'll explain what I mean. There are times that you would want to use one over the other. So for now, let's just say we are looking for the color or the light. Let me use light. Okay, say the light is equal to, we are asking you the user. So we'll call an input function to ask what color is the light. Okay, we want you to tell us what color the light is. Then once we've gotten that, we are going to check if the first statement is, we want to check if the light is equal to what color. Let's look for red first. If it is equal to red, let me just use small letters. I want to illustrate something, so we'll print what? Stop. Hey, stop. Okay, but else if, please don't forget that in Python, else if is written as elif. Okay, when you go to some other programming languages, you write else if light is equal to yellow, then what do? We say print get ready. Then the last one, we say else print, or better still, I prefer to actually check if it is green. So if light is green, then what do? Go ahead and print go. Okay. The reason why I had to come and check this is because I want to have an else block that will print wrong light, because a person can enter the wrong light color. Say this color doesn't exist on the traffic lights. Okay, so this is the basic program that when we run it, it's going to ask our user to tell us what the color of the light is. Then if they say red, we say hey stop. If they say yellow, we say get ready. If they say green, we say go. Let's run this and see if it gives us the output we are looking for. Okay, one advice that I've been given, let me iterate it now, is that don't be looking at these things and think that, oh yes, like as for this, I understand, I can do it, and not practice it. The best you can do for yourself is in your free time, you don't necessarily even have to come back to the video to see exactly what I wrote, but you yourself think through some of these things. Okay, some people come and they complain in my DM that I don't even know what to practice. These are some of the things. So as you come here, you get some idea. We are just imitating a traffic light. So when you go on your own, without looking at the video, try and see if you can build something like that. Okay, then you'll find out a lot of mistakes, if any. Then you learn from there. Okay, very important. In fact, there are quite a number of things that can go wrong with the program that we have right now, and that's where the learning actually is. So let's pay attention to that. chmod plus x, this is if start 2. Then let's run this program. If start 2, it says what color is the light, so say red. Say hey stop. Okay, then let me run it again. What color is the light? I say yellow. It says get ready. Then run it again. What color is the light? I say green. Say go. All right, let me run it again. And what color is the light? I say red. Please pay attention. Well, what do we expect? Let me pause here. What do we expect when I run this right now? If I click enter right now, what is it going to tell me? Yes, anyone? Yes. Oh, someone should just unmute and tell us.
To go to the else statement.
Okay. The else statements. Okay, you must say else statement. Tony, what did you say?
The else statement will evaluate because of your string is in cap. The range is cap lock. Yeah. Okay.
Ella, what did you say?
I said it will say that this color doesn't exist, which is what they were saying to go to the else statement.
Okay. All right. Good. So that's very important, especially if you are dealing with a programming language like Python. You can't let it go like that. This red is not the same as this red that we have. Okay? Because the red that we are checking it against is small letters or lowercase letters. But then what I have here is a capital R. So it tells me that this color doesn't exist. But how will our user get to know that he was supposed to type all in small caps? Okay, so these are some of the things that when you are practicing, it brings like the actual experience that you need to get as a programmer. These are the things that will bring it out. It's not just by following videos, okay? So that's why I'm challenging you that simple things like basic things that you do. These are decision making. So you can write program to make any kind of decision. Like every day you make decisions. Okay. So replicate all those your decision processes to a program. Just write a program that will simulate you making those decisions. Which book do you read? On what condition do you choose the book to read? Okay, when you get up, what do you do? On what condition do you choose to do what you want to do? Just write a simple program like that and you get to learn in the process. So let's correct this. How do we correct to say that no matter what a person types, we can actually pick this color, red? Okay, so there are several ways that you can go about this, and when you start thinking it through, you'll find one of the ways is to use integers to represent the colors from the start. So I could have said that let 1 represent red, 2 represent yellow, and 3 represents green. Then I'll ask the user to choose between those 3 numbers, 1, 2, 3. So when I come here, I'll only check for the numbers and I'll say, if you chose 1, then it means it was red, so print hey stop. If you chose 2, that was yellow, so print get ready. And if you chose 3, that's green, so go. But if you chose any other number, then the color doesn't exist. So I'll print the else statement. You see how I've solved that problem? So that's just one of the ways. There's no like this is the right way to solve it. It's just one of the ways that this problem can be solved. The other way that the problem can be solved is that whatever results that we get here, we can decide to convert it to a particular case. So we can decide to make it all caps and compare it against all caps. Since here we are comparing it against lowercase, we have to force this to lowercase, okay? So if you were here for the session on strings, you remember that I talked about string methods, and one of the methods is lower. So I can pass lower as a method. And what lower is doing is that anything at all that you pass, that a person is going to write, is going to convert everything to lowercase. So once I've converted it to lowercase, I can then go ahead and compare it with this color that I have here, okay? So all I'll need to do is pass lower here and pass lower here. There's a principle in programming called DRY, dry. Do not repeat yourself. So if your program is becoming that plenty, you should be able to take something else. So instead of doing light dots, what did I just do? Instead of doing light dots lower, I could probably find maybe a variable, a new variable, and call it whatever I want to call it, okay? Or I could actually pass the lower, I think that should work, the lower method on this directly, so that anything at all that you type will be stored in here with a lower, I mean lowercase, okay? But that is not the best thing, especially if, I mean not specifically with this program. Maybe I should take it one at a time. I'll get back to it. Let me just run this for us to see that it's working. So now we've implemented it using this lower, okay? Let's save this and run the program. Color red. And it says hey stop. So we see that we've remedied the situation by using that. Okay, and I was saying that instead of this, I have a high belief that we can easily do this lower, and that should also work, hopefully. Right. Then it says hey stop. So that has also worked. You see, some of these things you never know until you try them. Okay? You never know until you try them. So please and please, I'm pleading with you, sit down, try some of these examples. You yourself just try anything. If it doesn't work, you've learned it. Okay, you learn the way it doesn't work, then you learn the way it works. But then I'm saying right now that this is not preferred in certain circumstances. Okay, it's not preferred in certain circumstances where you need to remember the case the person used. What will it be? Let's say a password. Okay, let's assume that I think we should write something like that. Password checker. Okay, so let's write password.py. This program is going to check for passwords. So this is not different from the big things that you see, except that these are just the beginning parts. And without this knowledge, you can build the bigger applications, okay? But the concepts are the same. So what we intend to do here is we want to check maybe username against password and see if they match what we have in our database, sort of. Okay, then we'll grant the person access. So for instance, whenever you are logging into any platform, let's say Facebook, Twitter, any of those platforms, you enter your username, you enter your password. What happens is that they have your data already stored. When you create an account, they store it there. Okay, so the next time you want to log in, after you input your username and your password, is used to compare against those two. And these are conditionals. Like they go and compare if the username you provided is true. Then now let's go and also compare the password. If it is also true, then we'll give you access. Okay, so we want to implement something. So let's say login authentication. That's what we intend to do here. The first thing we want is store our username and password. Okay, so let me say username. Ideally, this would be in a database encrypted, all right? But for now, we don't really care. So let's say the username is admin. The password is for now, let's use a string that is RT21GH. Let me say this. Okay. Then let's build our program that's going to ask the user for their username and password. Okay. So the first thing I want to print is welcome to my app, my awesome app. So I print that to them. Then I ask them to input your username. Okay, input username. Then I go to input password. There's something I'm supposed to do that I've not done. Input password. I'm supposed to save these outcomes, okay, to a variable. So let's call a variable user password is equal to this. Then username is equal to this. So eventually when you are building your applications, this is the same logic you are going to be using, okay? Now we have taken the person's username, we've taken their password. What do we want to check? We want to check if, so that's the first thing we want to check. Your username is the same as the username that I have. So I'll check username. Username, if it is equal to the username that I have stored. So what I'm saying is ideally you would have this from, like you pull it from a database, or you check this username against a list of usernames in a database. Okay, so you go and check your database to find out if there is any username that is like what this person has entered. But for now, let's implement it this way. If it is, we are not done. We have to check it against the password too. So how do we do that? We use the AND to join the conditions. Okay, that's why I prefer to have the bracket. We use the AND to check for the passwords as well. Password is equal to password. So that's what we are checking for. If they are what we expect them to be, we'll say successfully logged in. Successfully logged in. Okay. Else, what do we say? Print incorrect combination. Okay. Great. So our login authentication platform is ready to work now. Remember, this will only be printed if the whole statement here is true. But these are two different conditions that have been combined with an end statement. So the first thing you want to do is to check if this is true. Then you check if this is true. Okay. So what I said here was, in this case, the case is very important. Unlike the other one where I was able to come and put, let's say for this in particular. So for the username, I can do the lower. But for password, it will not be appropriate for me to go and do the lower on it. Because the person has specific words, specific cases that they want it in that way. So when you're writing a program like this is what you go about to do. So you realize that, for instance, email addresses. If you write your email in caps or lowercase, nobody cares. It's still going to work. But then if you write your password in any case at all, it's not going to work, okay? So we can put the password here, the lower as part of the password to convert the password to lower. Let's run this, make it executable. Password, okay. Clear the screen, then run password and see. Says welcome to my awesome app. Username. My username is Obe. My password is 1234. It says incorrect combination. So maybe I'll add try again. Okay. I'll add try again. In fact, I think I should maintain this program. We'll come back later and make it more sophisticated. All right, but I believe that now everyone here understands the logic behind this program. It's only when I'm able to enter these two, when I'm asked, that is going to give me access and say successfully logged in. Okay, but then incorrect combination, sometimes this is too vague. What is the problem? Was the username right? And did we fail at the password? Was it the username that is not correct? Like all those things. So you realize that sometimes people make programs like this and using them isn't that easy. Okay, your logic becomes like, I don't know what is wrong. Like, is it my username that is wrong or is my password that I've forgotten? But all you are telling me is incorrect combination. So let's see if we can do something about it. Now we want to check the username. After we've gotten the username, we want to tell the user that, hey, you are using a wrong username, but maybe your password is right. In fact, if the first thing is, okay, maybe I shouldn't even go in there, but Later, when we start building web apps, we'll get there. So when you start building web apps, I'll walk you through it. But the logic here will be the first thing you check the username. You have to go and check your database if that username even exists. If it doesn't exist, why are you even checking for password? So you check if the username exists, then you go ahead and check for password. Okay, and if the password doesn't match, then you throw up the error that your password doesn't match your username. All right, so that would be it. I think we are good on the if else statements, and we have multiple of the conditions. So we could have also, how will I bring else if in here? So if they are not the same, okay. So I could have also brought an else if in here to check if any of them do else if. So if username is equal to username. Okay, so we are checking the first one. Sorry, this is else if. Okay, the first one was to check if both of them were correct. So if both of them are not correct, the next thing we want to check is, do you get the username right? If you got the username right, then I'll say wrong password. Wrong password. Okay, so that you know that is where your problem is coming from. Else, I'll come here and say, so it's either the password doesn't exist or, so the username doesn't exist. So this can be changed to username doesn't exist. So in simple terms, what's happening is that the first one, I'm checking whether your username and your password match. If they match, you have successfully logged in. But if they didn't match, it means that either this is false or this is false. So it's either your username is what is the problem or your password is what's the problem. So you come here to check the username. If the username is right, if the username is right, then we know that it's the password that was the problem and not the username. Okay, so let me go ahead and run this. Say our username, run the program. Clear. Our username is admin, and our password, I type 123. It says wrong password. So you see that it is the else if that is being executed. Wrong password. Because I had the right username, that's admin, but the password was wrong. Alright, if I run it again, then I give wrong username and wrong password. It tells me username doesn't exist. So where are we now? We are in the else block. So what happened was that it checked username and password. They are not, this condition rendered false. Then it came to the next condition to check, and it also rendered false. So it gave me the else block. Okay, let me copy this password because I don't remember. Okay, then now let's execute it and say password. Username is admin and password is this, and it says successfully logged in. Okay, so this is a very good practice that we have had on conditionals. When you go try and implement a login authentication system like this, because eventually when you start building applications, especially web apps that require that people log in, they are going to be needing a lot of this logic. Okay, so the earlier you start practicing, the better. Now let's move on. So hopefully you understand the conditionals. Now let's get to loops. All that we have been doing so far is we check for a condition and we do something. We check for a condition and we do something. We check for a condition and we do something. But what you realize is that whenever we check for a condition, it's only one thing that we are doing. So I check for if the username and the password are what I gave it, and if it was, I do something just once. What if I want to check for a condition, and if the condition is true, and for as long as that condition is true, I want to keep doing that thing? Let's take our traffic light example. You know that on your way that you are going, you don't have just one traffic light. There's a lot of traffic lights on your way, okay? But then you just checked once and you said, okay, go. When I meet the next one, what should I do? Okay, so anytime or in any case where you have to repeatedly make a decision, then we'll come to the concept of loops. Okay, so loop is actually an English word, going through the same cycle over and over and over. So basically, putting ourselves in a cycle. Okay, putting ourselves in a cycle. That is, we are repeatedly doing a particular thing. And over here, since we are trying to control the flow of our program, it is based on a condition. For as long as that condition is met, we are going to keep doing what we are doing. Okay? So you sit on a bicycle now, you want to move from here, point A to point B. And I tell you that paddle from point A to point B. Paddle until you get to your home. So what the condition is until you get to your destination. So as soon as you start paddling, you ask yourself, have I gotten to my destination? No. Paddle. Have I gotten to my destination? No. Paddle. Have I gotten to my destination? No. Paddle. Up to the point where you get to your destination. Have I gotten to my destination? Yes. Then you stop paddling. So basically, that is what the loops is about. You keep doing something until a condition becomes false. Remember that when we were dealing with the if statement, I talked about the condition being true. So here too, the condition has to be true. For as long as the condition is true, you are going to keep repeating it. Interestingly enough, loops, the concept is the same concept in every programming language. You understand it the same way you do use it in any programming language. However, when it comes to Python, or even depending on the programming language you're using, syntax becomes a bit different. And Python in particular has some sort of some difference that we need to pay attention to. Okay. So there are two types of loops in Python. We have the while loop. Then we have the for loop. Gordon, are you going to say something? Okay. So let's start with while loop. I think that is very easy. While loop. This is English. When you're writing your essays, you're writing, anytime you use while, you say while something, like while, then you give a condition. In normal English, while it is raining, stay indoors. What does it mean? You can only come out when it stops raining. Is that not it? I've given you a condition. Why is it raining? Stay indoors. So it means that you can't go outside whilst it is raining.
Hello, dog.
Hi. Hi, Jonathan.
Yeah, good evening.
Evening.
Yeah, please, I have a question based on the last, the one with the password stuff you created, please.
Okay.
Dot lower you key in there. That converts whenever you put capital. Sorry. The dot lower you put.
The lower.
You use what do you call it? I'm trying to remember. Even when you use capital letter, right?
This isn't this one you're referring to?
Yep. The dot lower there converts even if you put capital letters, right?
Yes. It will convert it to lower, like lowercase, all of them.
Okay.
Yeah.
Thank you.
You're welcome. So this is referred to as a string method. You know, the input is returning a string. Okay, there are a lot of them. We could even have, so if you want to convert everything to upper, you can also do upper. Okay, there's capitalize, and there is one that we even use to switch the case, that if it was capital, you switch it to lower, like that. So all of these, I think, yeah, I dealt with them, and I even showed how you can get a list of all the methods and what they mean during the session we had on strings. So if you've not checked it out, you can find time and take a look at that. Okay. So what did I say here? I said that if I tell you why it's raining, stay indoors, don't come out. That is a condition. So all that you are going to ask yourself, you keep asking yourself, is it raining? So while raining, in Python, you write it this way, then what you want a person to do. So I want you to stay indoors. Okay? So as for the while loop, this is how it works while it's raining. So it will come and check, is it raining? If it is raining, then you do this. Oh, did I say do? Stay. Okay? Then you stay indoors. After staying indoors for some time, you will now come back and say, is it raining? If it's still raining, stay indoors. Is it raining? If it's still raining, stay indoors. Is it raining? No, it has stopped raining. Then this is done. It has moved out of it. Okay? So remember that in execution of your program, it starts from top to bottom. So if I have something, let's say I have this program. This is an arbitrary program. Say a program that prints something, prints hey. Then the next thing is while I said it's arbitrary. While it's raining. Okay? While it's raining, prints stay indoors. Okay? Then prints let's go and play. Let's go and play. Okay, so let's assume that there's a program in Python. All that I've said is that in Python, the program, not in Python, almost every language, the program will execute from top to bottom. Okay, so ideally it will just go step by step, and go like that. But then today's session, we are learning about how to control that flow, and we are trying to control the flow with a loop here. Okay, so we created a loop with the while statement. So the first thing that this program does is it prints hey. Then it now gets to the while statement and it asks, is it raining? Okay, right now it's raining. So stay indoors. Then you will check again, is it raining? It's raining. Stay indoors. Is it raining? It will keep doing that till it is done raining. After it is done raining, then we'll get out of this loop and we'll come and print, let's go and play. So that's the concept. You use the loop to do something for as long as a condition that you are going to indicate in here remains. For those of you who partook in the PLD I held on conditionals and loops in C programming, I'm sure these things should make very much sense to you. Okay? If you haven't, you can always go back there and pay attention to that. But then, this is Python, so we have to learn how we are going to do it in Python. So what I remember talking about is that when you are using a loop, okay, when you are using a loop, there are three main things that you should consider. That is like in any programming language, there are three main things that you should consider. The first thing is initialization. So you initialize a variable, or if I can call it a counter, or something that will help you keep track of what you are doing, okay? Then the next thing is you look for a condition that you are going to be checking. Is this condition true? If it is true, then let's keep doing what we are doing. As soon as the condition becomes false, we'll stop doing what we're doing. Then the last thing is an increment or decrement, depending on what exactly we want to do. Increment or decrement. Okay, so I don't want to bring anything relating to C here. So I'm trying to limit myself to what they do in Python. Basically, if you are using the while loop, you would have to do the initialization. That is, initialize your variable before you write the while loop. Whatever you are going to use to keep track or the counter, initialize it outside before you introduce your while loop. Then, after you have your while loop, your condition will be inside this. Inviting, once again, the parenthesis is not important, but then I still like to use it. I don't know. All the other programming languages that I've used, they put it there, so I like to maintain it. Then, in the body of the loop, you want to either increment it or decrement it. So let's see a common example. Let's say that we want to print from 1 to 10. Okay? Print from 1 to 10. So we'll start our counter. Say counter is equal to 1. Then we'll write our while loop. We want to use this loop to print 1 to 10. Ideally, if I asked you to print 1 to 10 and you didn't have the loop, what you are going to do is you are going to start and do print 1, print 2, print 3, and that's quite tedious. And as I said earlier, in programming, we have a concept called DRY, dry. Don't repeat yourself. Okay, so anytime you start doing something, the same thing over and over, then there should be a way around to optimize it. Okay, so instead of doing this, we'll use the while loop. And basically, all the while loop is going to do, the condition here is we are printing up to 10. So we want to check if this counter has gotten to 10 yet. Okay, so that's basically what we are going to check. We're going to check if counter is less than 10, less than or equal to 10, because we want to print up to 10. As soon as counter becomes greater than 10, this condition is false. Remember what I talked about when we were checking conditions in the if statement. Always check if this is true. So if what I've written here is true, then the body of this while loop will be executed. So we'll come here and say print counter. Let me go and write this program so that you see it for yourself. Okay. Let me put it into a file. Call it counter.py. User bin Python 3. Okay, this is what prints from 1 to 10. Prints from 1 to 10. So the first thing we did was what our counter, initialize it. So this process is known as what? Initialization. Okay, then we write our while loop, put the condition here. My condition is I want to check if my counter is less than or equal to 10. So only when this condition is true should something be done. Okay, so here is condition. The body of this condition, so let me say this will only execute if the condition is true. At any point in time where the condition becomes false, this code that I'm writing currently will not be executed. So I want to print the counter. Okay, so if we go ahead and run this program, the first thing already counter is what? 1. We've set it to the 1. So we'll come and check counter. We know it to be 1. Is 1 less than or equal to 10? Okay, so that's the very first question here. You ask yourself, is 1? Forget about this counter because it's just a variable representing 1. So is 1 less than or equal to 10? You and I know that 1 is less than 10. So this condition now is true. Once it's true, we come in here and we say print counter. That is 1. So we'll print 1. Then I said it's a while loop. So it will come and do whatever it's done here. Now it will come back again and say while counter is less than or equal to 10. Counter as it stands now is still 1. Remember, we've not done anything to counter. We just went to print it. So it's still 1. Is 1 less than or equal to 10? Yes. It will come back and come and print again. So if we leave this code right now and we run it, it's just going to keep printing 1, 1, 1, 1 until my computer freezes. And that is what we call an infinite loop. So a loop that does not have a terminating condition or does not meet its terminating condition. Okay, so here what we need to do is to set something to increment counter. So we'll now say counter is going to be equal to the original counter plus 1. And this is what I was calling increment. We could be doing a decrement in some time, so I usually want to call it increment or decrement, depending on the condition I'm trying to achieve. Okay, so now what I've done here is that the first time when counter entered the loop, it was 1. And it printed this, it printed this. That is, it printed 1. Then after it got here, it was counter was now reset. So counter now became counter plus 1, which is 2. So we now get 2 is less than or equal to 10. Yes, it comes in here. 3. 3 is less than or equal to 10. Yes, print 3. Comes in here. 4. 4 is less than up to when we get to 10. 10 is less than or equal to 10. And that's true. 10 is equal to 10. So we'll come and print 10. Then we will still add another 1 to 10. Now counter has become 11. So when we enter here, 11 is less than or equal to 10. That is false. Once it is false, this loop is done. Okay, so maybe let me print something here and say your loop finally finished. I can't even see what I'm writing. Finished. Oh. Finished executing. Okay, so what's going to happen is that this line here will only be executed. The line here will only be executed if we are done with the loop. Until the loop finishes executing, we are not going here. Okay, so we are controlling the flow. Ideally, this was supposed to execute once, then we move to the next one, execute, move to the next one, execute. But this is a loop, so it keeps doing one thing over and over again. All right, so I need to make this executable. Counter, then let's run counter. Great, so as you can see, we've been able to print from 1 to 10. Okay, then finally it says your loop finally finished executing. So the long and short of it is that you need to have an initializer, something to initialize with, or something that you're going to use to keep track of the loop, the number of times your loop is executing. Okay, it depends exactly on what you are doing. In some cases, you may not need it. All right, there are cases where you may not need it. But if you want to keep track of it, especially for your condition sake, depends on what the condition is. Very soon, hopefully in the next PLD, we'll start talking about data structures and we'll learn going to use how we can use this without necessarily declaring an initializer. Okay, but for now, just remember that to use a while loop, you need to have an initializer set. That's like a tracker that you are going to use in your condition. And the condition could be anything. You could be checking for anything at all. But then what is important is for as long as the condition that you have here is true, then this is going to be executed. As soon as the condition tends to false, we are breaking out of this loop. Okay, we are going outside and doing something else. And even inside this loop, we can go ahead and check something. Check like if our counter. Please always remember that this parenthesis that I keep using is not compulsory. You can make do without a parenthesis. If counter is equal to, say, if it is equal to 4, I want to change. I no longer want to print the number 4. I want to print 4 as in string 4. Okay, so this is how with all the knowledge that we have been getting over the time, the things we've been learning, this is how you put them together to build sophisticated products or programs. Okay, it's just the basic things that we learned that we put together. So now I've been able to put an if condition inside a while loop. In fact, we can even do more. We can have multiple if statements. I can go ahead and even do else if here. Okay, else if say counter is equal to 5, then I'll print 5. Print 5. Okay, then so in fact this condition, for instance, if I don't want these ones to print, remember the flow, it prints in a particular order. Okay, so don't forget that. Then if it is not any of these, then go ahead and print just the number itself. So if I run this program, what I expect is that instead of the original 4 and 5 that we saw here, these two, 4 and 5 that we saw here, we'll now have 4 as a string and 5 as a string, I mean in West. So let me go ahead and run this again. You see, so 4 is written in West, 5 in West, just as I have here, because I put an if statement in there or a conditional statement in there to check if a particular condition is met. In the same way, I can still have another while loop in here. For each counter, I can have while loop in there, that is nested while loop. But then when we look at data structures, then we'll go more into the nested loops. But for now, I hope this makes sense. One thing that I should add before I jump to the for loop is that with the while loop, one interesting thing about it, which doesn't exist in other programming languages that I know about, is that while loop in Python can also have an else block. What do I mean by that? What I mean is that just as we have else, if the if statement is not met, I mean the condition in the if statement is not met or tends to become false, the else block will be executed. In the same way, with a while loop, we can create an else statement for a while loop. See how VS Code is aligning them for me. So this else statement is for the while. Okay, this else statement is for the if. Okay, in other languages, we don't have an else statement for while. In Python, we are going to be talking about for loop soon. In Python, we have else statement for both the for loop and the while loop. And basically, all that it does is you use the else statement to let it do something after the loop has executed. Okay, so if I want this, I could have written it this way, and all that is going to happen is that this else block will only wait until everything in the loop is completed. That is, until this condition becomes false. We are not going to execute what is here. Okay? We are not going to execute what is here until the condition becomes false and we get out of it. So if I run this program right now, it shouldn't give me any problems. I should have the same outcome as I had initially. Okay, so just as you are seeing, the same outcome as I had initially. All right. Sometimes it becomes important and you find out the importance when we start working with data structures. But then there is another, there are three things that I need to mention. Let me mention those ones so that when we go to the for loop, it becomes easier to finish. So that we would have talked about all of them here. There are three keywords that you need to pay attention to when working with loops in Python. In fact, I think they are available apart from one of them, but they are mostly, the concept is available in almost every programming language. So we have what we call break. We have continue. Then we have pass. As for break and continue, I think every programming language I know has it in there. But pass, I think only Python. For now, that's what I know. I may be wrong though, but I know it will be available in only Python. Okay, so before I even go in there, just picture it this way. Break is used to forcefully stop, hey, please let me stop. Then continue is used to skip. Just keep this in your mind. Then pass. What word will I use to represent pass? Pass is like
silence.
Go through an error. Yes, silence. Be silent. Thank you very much.
If you want to print all even numbers now, and you want to skip the odd ones, so I guess that's how it works.
Okay, I hear you, but you need to understand it better than just that. So let's see what's happening. When you say break, if you have a loop that you are running, okay, something that is going on, and you meet break, as soon as you say break, it means that we should get out of this loop. This loop has ended. Okay, so let's go and execute something else. The loop has already ended. If it is continue, continue is like, hey, continue what you are doing. Like, forget about me right now. I mean, skip this particular one that you are doing. Then continue with the next one. So I think our example that we are using is going to be good for it. As for pass, in Python, what happens is that you can't. So for now, permit me to just explain the break and the continue. When I'm done, then I'll talk about the pass. Okay, good. So same back to this program. We checked if counter was equal to 4 and we printed 4. What if we don't want to print 4? So let's assume that this your program is supposed to print everything but 4. It shouldn't print 4. So maybe let me create another one and call it 4 counter. Okay, just to represent that we are not going to print 4 here. Okay, so we check if counter is equal to 4. Then we are going to do something. What are we going to do? We said we don't want to print 4. Here, if you are printing something, fine. But then if counter is equal to 4, we want to skip that one. Remember, I said there is break for stop and there is continue for skip. So if I don't want to do anything when counter is equal to 4, then here I'll put continue, simple like that. All that it tells this program is that when you get here, when it is 4, skip, like skip 4, don't do any of these other things. Just go back to the while loop and start again. It's a loop. We are going round and round and round. Okay, and all that I've said here is that when you get to 4, skip. So it means I don't do anything to the 4, just jump over 4 and go to the next one. So when we have something like this, let me try and see if I can illustrate that implementation. When counter is 1, enters the loop. Counter is 1, it enters the loop. So we are checking if counter is less than or equal to 10. Okay, so the first time it enters, counter is 1. We end up printing 1. Okay, so this is to print counter. So the first time we print 1, then we increment counter. That's counter is equal to counter plus 1. That's what we are doing. So the next time, counter has now become 2. So we come and we print 2. It goes again, counter has become 3. Goes again, counter has become 4. Goes again, counter has become 5. Goes again, counter has become 7. 6. But then what we are trying to do is that when we get to 4, instead of printing 4, we want not to do anything with 4. So just go ahead and increase the counter, then continue the loop. Okay, that's all that we are trying to do with what we have here. So let's see. Let me run this. So we need to make this executable. chmod plus x4, then run. Okay. Ooh. Is it frozen? Or it has ended? So what is wrong? Let's debug it. Continue. I'm coming. Ooh, why is it hanging? So please pay attention here. Let me use this to explain pass. We have to debug it right now and find out why it's hanging. But then let's debug pass. Here, right now, because I've commented out this, okay, we are having an error. This tells us there is an error in the program. And Python in particular, you can't have an empty block of code after you have declared this column. Okay, so in order not for this to throw an error, you just put pass. So as somebody suggested, you make it silent. Instead of throwing that error that you didn't write anything for this block to be executed. Okay, without this, it's going to give you an error and you can't run your program. Okay, you need to have that running. Did I call the right one? Yeah. Okay, so we just put pass there so that we'll be able to run our code. Okay, so let me run it and see if I get. Okay, it's working fine. That means the problem was coming from our continue. Why was that a problem? Okay. So, okay. If I want to do that, I'd have to put the counter somewhere up there as well. Let's see. I'd have to, let me try this and see, then continue. If I don't want to print anything. Oh, yes. You have explained the logic right now, but you see that the outcome here, we don't have 4, we skipped the 4. Okay, what happened, as I was explaining earlier, was that when you say continue, it means that like this current loop that you are in, the session that you are in, forget about it, go to the next one. Okay, so without us increasing this, what we have done right now is when it gets to counter is equal to 4, we say continue. So it gets back here. Still, we didn't increase counter. Counter is still 4. So we'll get here and we check again. 4 is less than or equal to 10. If 4 is equal to 4, I mean if counter is 4, then continue. Then we'll go in there. So we have created an infinite loop just with that. Please, does it make sense? When I did this, as soon as you have the continue, all of these inside the loop is not going to be rendered because we said it should skip. Okay? We said it should skip. So as soon as it encounter this continue, then all of these will be skipped. Once it is skipped, our counter will keep being 4 all the time. So you can't and say 4 is less than or equal to 10. Yes. Then it gets in here. Coming. Then it gets in here and you still have counter is equal to 4. So you're going to have counter is equal to 4 all the time. And that is a problem. So we should increase this. We should increase this. Okay, I'm coming. Please give me some few seconds. Coming. Yeah. So please, let's continue from here. You have to do this adjustment if you want to use continue. But then, what I'm trying to illustrate to you right now is that what is important is when you use continue, we are skipping everything. Then going back to start the loop again. That's basically what skip is. If I use break, remember, the difference is that if I use break means that we should close the loop. Continue meant that skip this current one and go to the next one. So when I put continue here, and I had my counter set up here, all that I did was that initially, when it gets here and counter is equal to 4, then I'll do, okay, counter is equal to counter plus 1. So now counter has become 5. Then I say, hey, forget everything below, then come and check the next loop, like loop again and check, okay? Then if I don't want it that way, maybe I want to end the moment that we find counter to be 4. If I want to end the moment counter is 4, okay? So I'm not going, that means I'm going to print up to just 3. And after 3, I close the loop and I'm going to print the else statement or anything after the loop. So let's go ahead and execute this so you see. Where are you? Okay. So clear the screen, then run this again. And you see what just happened? This time around, we printed up to 3. 1, 2, and 3. And the reason why this is so is because we checked if counter is equal to 4. Then we brought a break. A break is get me out of this loop. I don't want to continue again. Get me out. The continue was skip this current one and go to the next iteration. I hope that makes sense. And all of these things, for now, you don't worry so much about it. Very soon, when we start using them to do practical things, then you see the import of them. So now you just need to understand what I mean when we say break, what I mean when we say continue, when do you use it. So for instance, if we were testing, remember when I was testing the code, I wanted to see if it was working. I used pass. Because if you don't write anything there, it's going to give you an error. So use pass mostly when you are testing something, you are yet to figure it out, or you are troubleshooting a problem. That's when you use pass. Use continue to skip and use break to get out of a loop. So that is for the while loops. Any question so far? Then let me finally talk about for loops.
Doc.
Hi, Ima.
Hello.
Yeah,
You
Ima.
see,
Are you
you see
able to
this,
see sessions?
you see this issue of while loop. Yeah? I think that's
Mm-hmm.
why most of people don't use it. Like what you explained initially. Suppose if it's in
Mm-hmm.
T, it's going to work like that. Instead of going to put the counter before the continue, it's supposed to work wherever the counter is, wherever the increment is at the end of the while loop. It's supposed to work, but now that you are putting it in before they continue, that's why it's kind of somehow difficult using while loop.
No,
Why?
come again. I'm trying to understand. It's not any different. So let me understand what the problem
I
is.
think
That's the content I have here.
it's kind of different when you
Mm-hmm.
compare it to C. If it's in C, you put it at the end. Put the increment at the end, and the whole thing will just be working fine.
No, relax, relax.
This one now, if you want to use the continue, you are putting it before the actual line that you want to use
No, no,
for the
no.
whole thing.
Ima, relax. It's the same thing. Okay, it's all about the logic and what you intend to do. This one that I have here, for instance, if I decide to carry this counter up here, it's allowed. It only depends on what I want to achieve. You realize that counter is 1, and I've entered here. Now I've checked 1 is less than or equal to 10, and I've come and said, okay, counter is equal to counter plus 1. That's the first thing I'm doing. So at the end of the day, before I come to check or I print anything, I've increased my counter. Okay, so it depends on where you want to put it. If I want to start printing from 2, because this one in particular, if I go ahead and execute it, it's going to execute, but then I'm going to start printing from 2. And let me run that. So you see, I don't have 1 printed here because I put my counter before my print statement. So it depends on what exactly you want to achieve. If you don't want the counter value to be recognized in the first place, then you can increment it. So for now, just understand how these things work. They work, it runs from top to bottom. Okay, there are situations where it is best to put it here. There are situations where you have to put it in the middle. There are situations where you have to put it in the last. The only important thing is that there should be something that will increase it so that you don't get an infinite loop. But the position doesn't matter, irrespective of the programming language you are using. The position doesn't matter. Then the issue with the continue that I had, as I explained earlier, let me go back to it. Okay, so when I put continue here, see, when I put continue here, what you are trying to do is that you are saying this continue means that it doesn't mean we should continue what we are doing. It means that we are done. Like right now, this current thing that you are doing, skip this one. Because the ideal thing is that when we enter the loop, we'll check this and do something. We check this and do something. We check this and do something. Up to when we get here. But the moment it says continue, what it means is that forget every other thing, like skip every other thing and go to the next one. That's what it means. So at the end of the day, when we get to 4, counter is equal to 4, and we have skipped all of these. We skipped all of them. Remember that as it stands now, your counter is 4, and you've not increased it. So when you come and check, counter is less than or equal to 10, it's still 4. So it's true. It will enter, continue, continue, continue. Nothing is happening. It's not printing anything because all that you are doing here is continue when it is 4. And the thing is still 4. So if you want to correct that problem, then you should find a way to correct it. I mean, to update the counter from 4. And it's just a peculiar, just an example. There are instances where when you use continue, you don't have to increase or decrease anything, depending on what you are doing. Okay? And don't worry, very soon when we start, working with data structures and using these loops with data structures, all those things will make sense. So if you still don't understand it, hold on. When we start doing working with list and co, I will try and explain it better for you. But then for now, know that you can put your counter anywhere you want. The past statement, the continuous statement means that skip. So if it is skipping, you should know exactly what to expect. You want it to increment before you skip it, or you want to keep it like that, okay? All right, hope that helps. Now let's talk about for loop. So I mentioned earlier that there is for loops in Python, except that it's a bit different from the for loops that we know. It's a bit different. How different is it? For Python, when you talk about a for loop, what you use it to do is you use the for loop to go through a sequence of data that you've been given. Okay? Then you apply a particular statement to each member of that sequence. Pay attention. For for loops in Python, what you use it to do is that you are given a sequence. So let's say a string that you are given, Obed. For this sequence of characters that is forming a string, if I use the for loop on it, what I'm trying to do is I'm going to do something that I state in the body of the for loop. I'm going to do it on each of the members of this sequence. That's basically what a for loop is. So, for instance, if I want to say print character by character, I can use a for loop to do that. And I'll say for, let's say, character. That's the variable name. Okay, it's a variable name that I'm using. For character in, that's a keyword in Python. In, Python understands it. In this string, okay? So all that I've done here is that for each of these things, for each of these characters, I want to do something with them. So I'll say print character. And basically all that I've done here is to use a loop. I'm looping through this sequence. And for each member, I'm doing something to it. For each member, I'm doing something to it. For each member, I'm doing something to it. So basically that is what the for loop is in Python. You are given a sequence and you want to operate on each member of the sequence. Then you use a for loop. Okay, so in that case, you can use your continue and your break to get out of the loop or skip a particular one of them. So assuming that I don't want to print E, or I don't want to print any vowel in there, I can use continue when I check for a vowel. So if it is a vowel, then skip it, go to the next one. Okay, so let's try that in code. Say print characters.py. Okay. With this, our program is going to, any name that you give it, is going to print it character by character. Say main.python 3. Alright. Then first of all, let's take your name as an input. Say input. Name. Okay. Then whatever the name is, we are using a for loop. Okay. And we want to print each character. So let me write a description for this. Print each character in a string. Okay, so we say for, let's call a character. So there's like the variable name. You can call it anything you want for C or for character. So for C, people usually like to use this. But it may end up confusing somebody thinking that I'm looking for C in the name. Okay, so maybe I should make it for car in the string. The string is name. What do I want to do? I want to print car. That's a simple thing. This is a simple loop. So at the end of the day, all that I'm doing here is that whatever name that you supplied here, I go in one after the other. Remember, I said for loops in Python, they just go through a sequence. Then they apply whatever you want to apply on each member of that sequence. So I'll say for character in name, print character. That means go through whatever the person types and print each member, print them. All right, so let's make this executable. Plus X, what's the name? Print car. Okay, and let's run print car. Ooh, line 5. For invalid syntax. Hope it's not because of this. Wow. For this in C, in name. Oh. So, guys, I hope you saw what just happened. I think I might have gone to use this is probably a keyword in Python that I haven't paid attention to. Okay, but then you could have called it anything. So I could have called it letter, but make sure that you are printing the letter or alphabet, anything. So for now, let's make it C. So for C in name, print C. So we just go ahead and run it and it says name. I say my name is Obed. So it prints O-B-E-D. So basically that's what a for loop is. You have a sequence, then it takes each member of the sequence and does something to it. So for instance, let's say for each member of the sequence, we want to print it multiple times. So I can say print it like 6 times. So we have O, 6 of them, B, 6 of them, like that. You can do almost anything that you want with it. I say Ehoneah, then run this. And as you can see, we have 6 times of E, 6 of this, 6 of that. The essence is that the for loop helps you take each member of a given sequence, then do something to it. So remember it's like that. Take a member of the sequence and do something to it. As simple as that. Okay. So I've said that we can include conditions in any of the loops. For instance, we can include an if statement and say if C is equal to, let me use E, is equal to E, then I want you to, so I don't want to print any E. Okay, so if I don't want to print any E, then what I'll do here is continue, because I'm trying to skip E. Anytime it's equal to E, just skip it. So what is going to happen is that it checks for C in name, I mean the character in the name, and if the character is E, it will move to the next character. Please remember that continue is for skip, so it won't come and execute this. Or move, go back to another, iteration. That's technically how we call it, another iteration. We'll go to the next character before it comes here. So let's try running the program again. See if we get any. Let's use Obed. So you see, we printed O, B's, and D's, but we skipped E's. Okay, so that's how you can go through a list of items, a range of numbers, a sequence of characters, anything, sequence of objects, like anything at all. Once you have a sequence of them, a group of them, a collection of them, however you want to call it, once you have that, you can use for loop to simply go one after the other. and do something to each of them. And with the power of this continuous statement, you can decide to skip some of them, skip over some of them. So I can combine this and check for, how do you call it, all the vowels. Maybe I want to print only the consonants, no vowels. So I can check for all of them and make sure I use continue after each of them. Okay, so in your spare time, try and implement something like that, where somebody gives you their name and you take out all the vowels from their names and you print out the consonants for them. That would be a good example to practice with. If I say break, what I'm saying is that anytime you see E, stop the loop. So if I write OBED, then it will go ahead and print O, go ahead and print B. Then the next one, which is E, the loop is going to end. So that will terminate the whole thing. Let's run this to show that. I say Obed. As you can see, it terminated right after B, because the next one is E, and you said if it is E, you should break out of the loop. So basically, that is how it works. If I am still contemplating on what to do here and I'm here to do that, I can put pass there and my program will not give me any error. So that is also what we use pass for. I don't think you have a program already working and you have pass in there. If you are debugging a program or you are yet to do something, you know you are going to do something, but you are just testing your code and you use the pass. Okay, I've illustrated. Okay, so the last thing I need to illustrate with the else statement would be to use the else. So I said earlier that both in Python, both the while loop and the for loop, they take the else statement, even though in other languages, the loops do not take else statement. So this else statement will print, it will execute once the loop has finished. There was something I should have said. Okay, let me say it here. So finally, loop finished executing. Okay. All right. So if I go ahead and I run this, I expect that as soon as this loop is done executing, this will be printed. Okay. Say Obed. Then as you can see here, finally loop finished executing. That is after it has executed everything you wanted it to execute. Okay. But then one thing about the else statement is that if the loop stops abruptly, if the loop, you break out of the loop, the else statement will not be executed. So instead of pass, if I now put break, what I've done here right now is that when it gets to E, it should stop executing the loop. Once I stop it like that, the else statement too is not going to be executed. So let's run this code and see. Say Obed. You see, it's ended after B because E is the next one, and we say that you should break if it is E. So the else statement was not executed. If I change this to continue, you'll find that the else statement will be executed. So pay attention to that. Like, there is logic behind all of these things, and very soon we'll start using them. But then all I need you to remember now is if you put break in any part of your loop, the body of the for statement or the while statement, if there is a break there and the condition is met such that you are breaking out of it, else will not be executed. Otherwise, else will always be executed as soon as the loop is done executing. So as you can see here, else has been executed. One final thing about the for statement, we can use it with a lot of things, but now I've used it with a string and I want to use it with a range as well. That would be simple. This function, you need to know about it because it's going to be very useful. Range. Okay, so range as a function gives us, even though we are here to talk about list, but it gives us like a sequence of numbers. Range. So if I say, let's say 5, please pay attention to this. it's going to give us 5 iterations because you said 5, the range is 5. So it's like first, second, third, fourth, fifth. So if I'm going to do something in this range, okay, maybe all right, let me change this. We'll be using more of this when we start when we start talking about data structures, lists, dictionaries, and co. But then that will be our next thing. So I don't want to bore you with those ones. Okay, let's go ahead and run this. Oh, why am I even still requiring him? Okay, so what you can see here is that there are 5 iterations and we are printing each of the iterations. But then it starts from 0. Remember this, range always starts from 0. So even though you've written 5 here, it starts from 0 and ends at 4. And this is the reason, because 0 is also one of them. So we have 1, 2, 3, 4, 5. There are 5 iterations here, like it moves 5 times. Okay, so for now, just remember you can use range as well to, it will come in handy very soon. In fact, we can use it to get, we can get the length of something and use, let me not worry you right now. For now, let's stick to the strings. When we learn the data structures, we'll make good use of these ones. So it could be any string at all, but then I think the meaning has been carried across. You use the for loop to go through a sequence of characters, a sequence of objects, a sequence of whatever sequence that you have. You use it to go through each of them and apply a particular condition or statement to that sequence. I hope that makes sense. If you have any questions, time for questioning. Yes, let me answer the questions then. We can call it a day. Questions? Then I guess there are no questions.
Yeah, Doc, I just remember something now. This else statement, even though this is the first time I'm seeing it, this else statement in the while and in the for loop, especially the for loop, when exactly is it needed? As in, when is the right time to make use of them?
Yeah. So just as I said, when we start using these loops with the data structures, you will find various uses for it. Okay, but essentially all that is happening is, hey, do this once the loop has finished executing. So one thing that you can do is, let's say in searching, if you are searching for something, okay, let me see, let's say I was searching for the character F in the name that the person enters. Okay, say if character is equal to F. If it is equal to F, that's only when I'm going to print the character. Let's assume that's what I want. I want to print the character F if the person has F. Why? Why is it giving me the indentation?
No, you're using this thing.
Okay.
1C. Sorry, double.
Okay.
Yeah.
Thank you. Sorry. Yeah. So here the logic is that I'm going to check if there is an F in my statement. I mean, in the name the person enters, then I'll type that. I'll print that. If there is no F, then I want to say you didn't find what you were looking for. Okay. So you can use it for searching for things. You didn't find what you were looking for. Okay, so what is happening right now is, we know that anytime we use the break, else will not be executed. And we are using the break as soon as we find this character in the name. If we didn't find it and everything has ended, like we've gone through everything, then we are going to be executing this. So let's try running our program now. the name is Obed, and it says you didn't find what you were looking for. Okay, but if I run the program and I say my name is Francis and I run it, oh no. Okay, so it's because
it's correct. It's correct. It's because Francis is capital F and you're looking for small F.
Oh, sorry, I didn't pay attention to
Make it
that.
small F. Make Francis small F.
Okay, so what we could have done as well was to use the lower method on this. You know, this is very good. Thanks for picking it up. So now I can go ahead and use Francis. And it gives me the outcome. So I hope you see the application there. That's just one application. You can use it to help you search for something and give correct feedback. Okay, so basically I'm giving feedback after the loop has done something. Okay, if what you are looking for was not there, then you use the else block to give that feedback. But essentially, I believe you can even go without it, because you could have used, let's say, an else block here, or probably check later. I mean, there are ways to go about it. It has its own use, though. That's why you don't find it in other languages. Exactly. You can use else if as well.
Okay,
that's why you don't find it in other languages. But we'll talk about like two other uses when we start looking at the working with the various data structures. Okay. You're welcome. Thank you all so much for joining. I appreciate your time, and hopefully this weekend I don't think we'll be able to meet because